Oh yeah, we're going to have a bit of a talk about mechanical displays. Actual 7-segment displays, but are mechanical rather than LED. Now I was on holiday at Christmas in the Canary Islands, and they had these signs down by the beach, and they alternate between time and temperature. And I thought, I really like those. I'd like to make one of those for my garden. Obviously not 11 foot high and green, because obviously the wife might have something to say about that. But I thought I'd make a smaller one and make it sort of A4 size, put it in a weatherproof box, and I stick it on the side of the shed or something like that. So when I got home, I thought, right, I'll find something to make a display with, because I didn't have any hope of finding those actual mechanical displays. So I sat down and thought I'll do it with LEDs or something like that, and luckily I found these on eBay, actual mechanical displays. Now these are probably decades old, but there's a guy on there selling them at the moment, and I've set this up to do exactly what the one I saw on holiday did. It literally swaps between temperature and time every 10 seconds. It's based on Arduino Uno, and I shall take you through my journey learning how to use these and how to code them and how to make them do what you want. First of all, how do these things work? Well, they literally flip the segment in and out of view through about 90 degrees with some little coils. Simple as that. They're on hinges and they flip in and out of view. The great thing about that is that in bright sunlight, these are super visible. LEDs haven't always been as good as they are now, and in years gone by there's no way you could have made an outdoor LED display because nobody would have been able to see it or read it. So these are the sort of things they use in cricket scoreboards and tennis scoreboards, anything that requires some high visibility digits to be seen in direct sunlight. I think this sort of size would have been the sort of thing you'd have found in the first digital petrol pumps and things like that, or a weighbridge or some other outdoor display. Anyway, I'll take you through the components and we'll look in a bit more detail about how these work, how to drive them, how to connect them up. I'll do it in several videos, well probably 2 videos, one addressing the code and one addressing the hardware. First of all, I'll show you what the layout is here. You've got our 4 digits here, basically screwed to a piece of, a couple of rails of metal to keep everything nice and solid. Real-time clock. I won't spend much time on this because there'll be hundreds of videos on YouTube how to use an Arduino real-time clock. 4 pins, well 2 pins and power into your Arduino. This is a thermistor temperature sensor. It's literally a resistor that changes resistance with temperature. I prefer these to those horrible Chinese little white things you can get that do temperature. They're easier to use, they're more accurate, and this particular one is in an outdoor thermometer shield, so it's perfect. You can bolt this thing straight outdoors. It's designed so the sun can't shine on it and give you false readings. It's perfect for this job. Again, I won't go into how we read temperature off this. It's literally read into an analog port and a couple of calculations and you've got temperature. It's easy. Might cover that in another video. This is what we're more interested in, these displays. Now quickly, if we look at one segment, how it works, let's take one segment there like that one. It's on a hinge, as you can see. It flips in and out of view. It's flipped in and out of view by a coil. Well, more accurately to say, it's flipped in and out of view by 2 coils. What you have is you have a common bobbin, looks for all the world like a relay coil, and you have a common, and you have a show coil and a hide coil. And that's the 3 pins on each segment that you see there. What happens is, let's just for instance say you put 0 volts on there, a pulse of 12 volts on there, and it will hide that segment. A pulse of 12 volts on here, and it will show that segment. All it does is change the polarity of the magnet on this little electromagnet and flip it either way in reaction to another little magnet in the segment. Flip it either way on a hinge. So we've got 3 connections for each segment. That gives us 21 connections for 1 digit. that gives us 84 connections for a 4-digit display. Now that's a hell of a lot of wires. It's a hell of a lot of pins on the back of there. So somehow we've got to crunch that down into such a format that an Arduino Uno can talk to this lot with the few pins that's available on the Arduino Uno, which is about 11, I think it's about 11 or 12 digital output pins. And to do that, obviously something has to happen in the middle. The other thing is, obviously this works at 12 volts, that works at 5 volts. Something has to be done to change the voltage level. These coils take quite a lot of current. Again, the Arduino couldn't drive that sort of current. So the board in the middle handles all that. I will take you through stage by stage what's happening on that board. It's just a piece of Vero board off eBay with some cheap and cheerful off-the-shelf chips soldered onto it. I'll take you through how that works anyway. First of all, let's get this pin count down on here. We've got 84 pins to start with on here. Obviously there aren't 84 wires coming out of there. There's quite a few wires, but there aren't 84. The first thing we do, if we draw these displays, apologise in advance for my crappy drawings. There's our 4 displays. First of all, we've got 7 commons on each display to these coils. We connect all them together, so we end up with 1 common out of each display. Yeah, and then we pull them out on a buzz like that. 4 commons times 4 commons. So they come out. And the next thing we do is all the segments that are similar in each display, the same segments, we wire those together and fetch those out. So obviously we end up 7 segments, we end up with times 7 segments. And then you've got to remember there are obviously 2 coils per segment, so we do that all again for the other coils. So we end up with another times 7 segments. So these coils will be the show coils, those coils will be the hide coils, and those will be the common. So now we're down to 18 pins from 84, which is very good. It's certainly a lot better than having 84 to try and connect to. And we can do everything we need to do with those 18 pins. We can address any particular segment with certain combinations of highs and lows on these pins. So that's how the display is connected up. One other little thing I'll mention, if you're going to be doing these, you do need diodes. Every coil you will need to solder a diode in like that, because well, we're using positive commons for those, because you get feedback through the coils. When you're trying to talk to one display, there will be leakage through the other coils and you'll never be able to make it work. So hence there are like a million diodes on the back of there. You can't just wire them up, you've got to take diodes off. Believe me, it won't work without. I tried it. I tried to skip the step with the diodes. So right, we end up with 14 wires here to these displays, and obviously 18 wires to these displays. Obviously there still aren't 18 outputs we can use on that Arduino. So the next phase is what's happening with this board. Now I'll tell you what's going on with this board. So we have 4 commons to talk to, and then 2 buzzes. 1, 2, 3, 4, 5, 6. I'll just draw these in. 2 buzzes of show coils and hide coils. The commons are easy. We literally get this chip here, which is a UDN 2981. I love these driver chips, they're great. There's a whole family of these things, like the UDNs and ULNs, that are absolutely perfect for this job, because they're designed for a microprocessor to talk to one side and then you switch your high voltages with the other. If we look at one channel of this UDN, it is literally what we call a high side buffer. The Arduino goes here, that goes up 0 to 5, and that will go up 0 to 12. So there you've accomplished your level change and your higher current handling. So your 4 commons, basically, I won't draw them all, but your 4 commons basically go to the Arduino. Simple as that. So that is your 4 commons taken care of. that chip, Arduino. So that's easy. The next bit is a little bit more complicated. Now these supply the positives when we need them to give a positive to these displays, and then the other side, the two lots of 7s, switch the negatives. So what we do with those, we have another chip, which is another favourite chip of mine, called the ULN 2003A. ULN 2003A. And that's the opposite of that. This is what's called a low side buffer. What you've got in there is exactly the same, but it's an inverting buffer. In other words, it's a pull down, it supplies a 0 volt. So again, 0 and 5 here, logic 1 and 0 from your Arduino gives a 0 volt there when that is high. So between these two, we've got a positive here, we've got our coil for show or hide, which is inside the display, and the path there is back through the other chip to ground. So between this chip and those two chips, we can switch any particular segment in any of these displays. So the next thing, again, this is repeated here for your hide segment. So 7 show, 7 hide, 4 commons. Now the next chip we've got is these two here. Now these are a very clever little chip. These are shift registers. Now obviously people are watching this, maybe watching this, who are absolute beginners, and there are other people watching this that may be gods of electronics that are not fit to shine their shoes. So I've got to pit it somewhere in the middle about how these work. If you imagine a shift register, it's a chip with 8 pins coming out, which can give me a binary number. Yep. And coming in, there's one data line. And what it does is there's a function already built into your Arduino functions called shift out. And that'll take a byte variable out of your code, out of your sketch, and it will send it down one wire. So it will literally, your byte variable, it will fire down one wire in a serial format as a series of pulses, for want of a better description, yeah, down the one wire. It then gets stacked up in here, and you have another wire called your latch, another pin called your latch, which your Arduino operates, and when it operates it, your byte that has gone in on one wire gets fired out on 8. So from one pin of your Arduino, you've managed to get 8 parallel outputs. Again, perfect for this. So these next two chips here are these, which is the 74HC 595, yes, 595. So your 595s sit there, and they're literally wired straight across. So by the way, the 595 will do 8 bits. We only need 7, so the last significant bit, the last bit is left out. We don't use that, it's just not connected. So we have our 7-bit wide buzz there and a 7-bit wide buzz there to our buffers, out to our segments. In from the Arduino we have data, and that brings me to another little thing about these 595s. They can be stacked up, so you can put another one here, and there's a pin you can connect to the next one, which means you can send 2 bytes, or however many you like. You can send 2 bytes down this same wire, and it will go through that chip into that chip, and then the second byte instead will go into the first chip. So now we've got 16 parallel output lines from a single Arduino wire. So that's how we end up getting these enormous number of pins shunted down to basically they are just a few wires from the Arduino. So the Arduino ends up with 4 enable lines going out to your commons, digital outputs, data, latch. That is the line that the Arduino fetches high to tell that chip to spit that out, yeah. And it also tells this 595 when to expect data from the Arduino. The last pin that we're going to use on these chips is clock. all that does, it tells these chips, it keeps these chips in synchronization with your Arduino to tell it where the bits are going to appear, for want of a better word, because these chips have no idea how fast this data is going to come, so the clock keeps them in check. And these are repeated over to this second chip, and then you've got the wire between the chips, so that's what we end up with. The data's fired out down here as 2 bytes. It goes through the first chip into the second chip. The first byte you send gets clocked out to those 7 segments, and the second byte gets clocked out to the other 7 segments, and that's what's on that board. The only other thing on that board, there's a 5 volt regulator which powers the Arduino. I always do a separate regulator, I'm not sure why, but I do. And just a couple of components there for a resistive divider and a capacitor there, which makes my thermistor work in here to give me a temperature reading. Yeah, it really is 14 degrees in here, it's freezing. I've got a big fire on, so it's alright. So that is the setup for this. Not very difficult to wire up really. If you do, the thing is with Vero board is you do your planning first. Get a piece of paper out, turn your chips upside down and round and round to find out the best way you can do it with the least number of solder tracks and the least number of links. So that is the board, so that's what it does. So I'm going to do a little thing on the software on this, on the code, on another video to say how this all works. These displays, by the way, we could probably update these 4 displays almost as fast as you could see in one click, but the ones I saw on the beach that I liked so much, they did it exactly like this, click, 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 and I like that, so I've copied it. So there's a deliberate delay there. So anyway, so thanks for watching, and I shall do another little one saying what the code is to drive this. I share all my diagrams and code online if anybody wants it, so it's I'm happy to send anybody my sketch, my code for these things. So if anyone wants to build one, you can always give me a shout, but I'll see you in the next video. Thank you.